Hi guys, I'm going to go through some examples for factoring trinomials when your a value is no longer equal to 1. I'm going to go through 2 example problems, and then if you want to skip forward and watch and skip the rest of the video to check your answers at the end, you're more than welcome to. I'll also keep on going and do more than just those 2 examples if that's what you need. So let's look at the first one together. Off to the side, I'm going to list what does A equal, what does B equal, what does C equal. In this case, A is 7, B is a negative 16, and C is a negative 15. So I'm going to fill out my snowflake. This one's a little bit different because A is no longer 1. So in the A spots, I'm going to put my 7. In the A times, I'm going to take my A times C. So I'm taking 7 times a negative 15. 7 times negative 15. And positive times a negative, I know this number is going to be negative. I'm going to use my multiplication table to figure out what that will be. 7 times 15 will leave me with 105. Negative 105. Okay, and my B value is going to be a negative 16. Okay, from here, I'm going to now factor out A times C. I've got a pretty big number, but that's okay. So I've got negative 105. And I'm going to list out all of my factors. So I've got 1 and 105. 2 does not go into 105. 3, I don't believe goes in. We can check. I don't think it does. 4 doesn't go in, but 5 does. If I look at my multiplication table, I'm going to zoom out just a little bit. I've got a 105 here. So 5 goes in 21 times. So I've got 5 and 21. And if I just keep looking for those 105s, it's going to happen again here at 7 and 15. We're going to keep going, keep on looking for those 105s. The next one, it looks like, is at 7 and 15, so I've gotten all of them. I want to figure out which of these will add to a negative 16. So that means that one of my numbers has to be negative. Well, 1 plus 105, that's not going to work. I'm never going to get 16 from there. 15 and 21. If I were to subtract 5 and 21, 21 minus 5, I'll get to 16. In order to get to a negative 16, 21 has to be negative, 5 has to be positive. So negative 21 plus 5 will give me a negative 16, which means that these are going to be my 2 factors. So 5 and a negative 21. Okay, from there, I'm going to look at my fractions that I've kind of created with this A and C. So here and here. I want to figure out if I can simplify or reduce either of those fractions. With this first one, 7 and 5, they have no common factors. I can't divide. The only number I can divide into both is 1. So that one's going to stay the same. The A is going to go in front of my X, and then I have a positive 5 at the bottom. I'm going to set up my fraction or my binomial for the next one over here. 7 over negative 21. Do I have any common factors for 7 and negative 21? Yeah, both can be divided by 7. When I do that, 7 divided by 7 leaves me with 1. Negative 21 divided by 7 leaves me with a negative 3. So this is going to be my new fraction, 1 over negative 3. So I'm going to put the 1 in front of my x, and then I've got a minus 3. And that will be my final answer. Okay, let's look at number 2. After this one, if you want to fast forward, you're more than welcome to. Off to the side, A equals, B equals, C equals. Great. A is equal to 7, B is equal to 32, C is equal to a negative 15. So I'm going to factor this one out. A is going to go here and here, so I've got 7 and 7. A times C, so 7 times a negative 15. Oh, I got the same values I had over here. This is going to multiply to a negative 105. My B value is a positive 32. Okay, from there, I'm going to factor out my negative 105. I'm going to list the factors that I came up with last time. So I have 1 and 105, 5 and a negative 21, and 7 and 15. 5 and positive 21. Unfortunately, if I'm multiplying to a negative, one of these numbers has to be negative. And I actually can't get any of these to multiply to a negative, to add to a positive 32. So that means that I'm missing one factor. Any idea of what it might be? So I see that 15 goes into 105. Well, my factors of 15 are 3 times 5. I've got my 5 here, but that means that 3 has to go into 105. So I'm going to just do a little division off to the side up here, a little long division since it's not in my multiplication table. 3 goes into 10 3 times. So I've got 9, subtract, I bring down a 1, carry down my 5. 3 goes into 15 5 times. So 3 times 35 will get me to a positive, or to 105. And if I've got a negative, if 3 is negative, negative 3 plus 35 will get me to a positive 32. So those are going to be my two factors, negative 3 and a positive 35. Okay, from here, again, I'm going to look at those two fractions. So I've got a 7 over 3, and I've got a 7 over 35. Looking at the fraction on the right, on the left, this fraction, 7 over negative 3, there's no common factors, so I can't reduce it any further. It's all the way reduced. It's going to stay as it is. 7 goes in front of my x, or in this case my r, and then I have a minus 3 at the end. Looking at my second fraction, 7 and 35, what's my common factor to both of these? 7. I can divide 7 by 7 and 35 by 7. 7 by 7 will leave me with 1, and 35 divided by 7 will leave me with 5. So my 1 is going to go in front of my r, and then I have a positive 5 at the end. And that will be my factored form. Okay, at this point, if you would like to continue on your own, you are more than welcome to. If you would like to continue watching and go through 2 more examples, I'll keep going with these 2 next ones. So go ahead and make that decision now. Okay, continuing with number 3 and 4. So again, I'm going to start off number 3, listing out what is A, what is B, what is C. In this case, A is 2, B is 5, and C is 3. So I'm going to set up my snowflake. In my A spots, I'm going to put my 2. A times C is going to be that 2 times 3, or a positive 6 up here. And my B value is 5. So I'm going to factor out A times C, factor out 6 off to the side. Go ahead and list out all of your factors. You should have 1 and 6, and 2 and 3, and that's really it for 6. Since this is a positive number and this is a positive number, I don't have to worry about any negatives. Which of these, if I added them straight across, would add to 5? That's 2 times 3. So 2 and 3 will be my 2 factors. I'm going to look at my fractions. Looking at this first one, Can I divide 2 and 2 by the same number? Yeah, I can divide both of them by 2. So when I do that, I get a fraction of 1 over 1. So my first set, or my first binomial, will be 1k, and then I have a positive 1, so I'm going to put plus 1. Looking at my second set of fractions, 2 over 3, there's no factor or no number that goes into both of these except for 1. So that means this fraction is completely reduced. The 2 is going to go in front of k, and then I've got a plus 3 at the end. And that'll be it. Okay, let's look at number 4. So again, I'm going to start off, what is A, what is B, what is C? In this case, A is 3, B is 5, and C is a negative 8. Let's fill out my snowflake. A is going to go here and here, so I've got a 3 here and a 3 here. A times C is a 3 times negative 8, which will give me a negative 24. And my B value is 5. Okay, from here I'm going to factor out A times C, so A times C was a negative 24. Go ahead and look at your multiplication chart. What are all of your factors of 24? You should have 1 and 24. 2 goes into 24 how many times? 12. 3 goes into 24 8 times. 4 goes into 24 6 times. 5 does not go in, and then we're back at 6. So these are going to be all of my factors of 24. Since one of these numbers is negative, I'm multiplying to a negative. That means that one of my factor pairs, one of the numbers has to be negative, and I've got to add to a positive 5. So looking, which one of these could add to a positive 5 if one of the numbers were negative? Okay, this one, 8 and 3, if I take 8 minus 3, I'm going to end up at a positive 5. So in order to have 8 minus 3, this 3 has to be negative. So I'm going to copy those pairs down. So I've got a negative 3 and a positive 8. I'm going to look at my two fractions. Looking at the first one, 3 over negative 3. Can I reduce that, or is there a number that divides into both 3 and 3? Yes, 3 does. So I'm going to divide both of these numbers by 3 so that I end up with a 1 over a negative 1, just kind of like the last one. So in that case, my first binomial will be a 1x minus 1. Looking at the second pair, 3 over 8. There are no common factors that go into 3 and 8, so this one's going to stay the same. I'm going to have a 3x, and then I'll have a plus 8 at the end. And that'll be it. Go ahead and pause. You're going to you're going to work through the next couple pages of problems. You can click to the next check mark to check your answers. Go ahead and get started. Checking your answers, you're going to check your answers to number 3 and number 4. Looking at the back side, some of these numbers got pretty large, so hopefully you're using your calculator to figure out all of your factors. 5 and 6, 7 and 8, 9 and 10. If you got any of those wrong, take a moment and just pause to correct any. Call me over if you can't find your mistake. Your answers to numbers 11 and 12. 13 and 14, and 15 and 16. You're done. You don't need to do numbers 17, 18, 19, or 20. You're going to move on to the next piece in the agenda.